Hello and welcome. I'm Adam with Pushing Envelope, the channel that gives you everything artificial intelligence and machine learning. It's been a few weeks, but I'm back with a new video, and this time we're going to be covering pandas. Now, I've already done pandas in a previous video, and we covered the very basics of how to use it. But this video, we're going to be focusing on how do we use more advanced features within pandas to really unlock what the package is meant for, and that is manipulating a lot of data super quick. So we're going to be going over how we originally may have done functions and how pandas can be optimized in order to make them run a little faster. So without further ado, let's jump over to the Jupyter Notebook. All right, let's go ahead and get started. As you can see on the very top, I do have a link to my GitHub, and that's where I am storing the templates for this tutorial. You don't necessarily need them. You can follow along without them. Also, if you haven't looked at the first video when we went over the very basics of pandas, you might want to go check that out. I'll go ahead and link that right now. You can go watch that quickly and come back. But go ahead, jump to this GitHub link if you want to. Go download those and come back. I'm going to be running through the template right now. So we're going to be going over some basic functions. As you can see, I already have them sort of laid out. But first, we really need a data set to start testing this stuff on. So if I open this a little, I already have the code written for getting this data set. If you want to pause the video, you can go ahead and copy this down and run it yourselves. But basically what I'm doing, I'm using Y-Finance to get finance data. I'm going to be reading in two tickers, so Apple and Triple M. 3M that is. And then I'm going to be making a dictionary based on their sectors. So Apple's going to be tech, and 3M is going to be industrials. Once I do that, I'm going to use the Yahoo Finance.download to download the ticker. And then I'm just going to do some pre-processing to add the ticker as one of the columns. I'm also going to convert the date to string so that we can use that later. And then I'm going to reorder it. So it's all fairly basic. I'm not going to go through this. I do have some other tutorials on using actual finance data for stock market predictions if you want to go check that out. But for the point of this tutorial, I'm not going to worry about it. So I'm going to go ahead and run this. May take a second to download each individual stock, but nope, there we go. Okay, so what you're going to get is a data frame with the date, the ticker, the opening, high, low, close, adjusted close, and the volume for each day. And that's going to come to 25,785 rows. So we got a decent chunk of data here. You're really going to see the benefit from pandas when you have super large data sets. So this one's fairly small, but we're going to run it quite a bit to see what the actual performance is. All right, so let's get right into it. First thing we're going to look at is how do we optimally read in dates for pandas. So I have each one of these tutorials. I kind of have how we originally may have done it, and I'm going to show also what is the optimal solution to doing it. So right here in the original, you can see that basically we're just doing a for loop. We're going through each of the dates within the stock. We are using the date time package in order to convert the string into a date, and then we're appending that into a big list. And at the very end, we're making a new column with that with those dates. Now, the problem with this and the problem with a lot of these is we're using this for loop. So we have to loop through every single thing within the data frame. And that is very costly, especially when you have super large data frames that you're trying to loop through. So we really need an optimal solution so that we can totally avoid this for loop and do it in basically one shot. And the good thing about that is Pandas comes with a built-in function for converting strings to date times. So if you haven't seen this before, if you're using IPython notebooks, Jupyter Lab, Jupyter Notebook, anything like that, you can do a double %sign, time it, and time it is going to record how long it takes the cell to execute. But more than that, you can figure out how many runs and how many number of times you want to loop through this in order to test it multiple times to try to get statistical significance and get a better idea of what the average runtime was and what the standard deviation was. So we're going to use time it. I'm going with 3 runs, and each run is going to consist of 100 iterations, so 100 loops within there. And you'll see what that does. Actually, you can see it up here already. I've already run the original cells because I don't want to wait for these to execute. But you can see when the original cell was run for 3 loops and 3 runs with 100 loops each, it averaged 213 milliseconds with a standard deviation of 979 microseconds. That's basically what it's doing here. Okay, so let's get into it. So Pandas comes with a date time conversion already built into it. So our data frame is called stocks. And I'm just going to create a new column called new dates. Just call it new date. Okay, so new date is going to be equal to PD. I imported pandas as PD. If you didn't, just go ahead and write pandas. So PD dot to underscore date time. And this is the function that converts a column of strings into a datetime format, assuming that it's following a standard format for the string. So we're going to be converting the stocks data frame at the date column to the datetime. Now, before I run this I am going to comment this out, and I'm just going to display the stocks data frame, just so you can see that we are now converting into a new date. So we have the original date, we have the new date. If I do .dtypes, you can see the original date is an object, so it was a string, and the new date is a datetime. So that's how you convert to datetimes. And if I go ahead, delete the display and undo the time it, we're going to let this run, and we're going to see how long it takes to run for the same number as before. Now, as you can see, before it took 213 milliseconds on average. Now it's taking 16.8 milliseconds. So definitely saving a lot of time doing it this way. Okay, so that's one of the more basic ones. But let's get into something that's probably the most important thing with pandas, and that's indexing. So trying to find different values within the data set. I have, again, an original one up here. And in this case, our original is doing a for loop over all of the data. And it's looking for whenever the year is equal to the current year, 2022. When it finds that, it's collecting all of the closing prices. So all of this is doing right here is I want to know what the closing prices were for 2022 and only 2022. As you can see, running this, it took 258 milliseconds on average. So let's try to reduce that. And there's a couple ways that we can do this. So I'm going to say closes. This is where I'm going to store all of the closing prices. But closes is going to be equal to stocks. And then we're going to do a square bracket. So now is where we're looking for some sort of condition. So I want to know when the stocks at new date. Now remember, new date is the column I just created, and that is the date times. So I want to know when new date.dt for datetime .year. So I'm pulling all the years from the dates. I want to know when that year is equal to 2022. Make sure to end your square bracket. And then I want to pull out the close column. And what this is going to do is it's going to pull out wherever the year is equal to 2022. It's going to take all those values in the close column, and it's going to save it to the variable close. Again, I'm going to I'm going to comment the time it. I'm just going to print closes so you can see what it looks like. And I misspelled stocks. There we go. As you can see, we have all of the closing prices, and it looks like there were 328 for this year. Okay. I'm going to uncomment time it, and we're going to go ahead and run this for real. And you could see very quickly 2.99 milliseconds we were able to run this. So definitely able to save a lot of time doing it this way. Now I'm going to show you one other way, and this is probably the best way I recommend to do it. We're going to say closes again. This time closes is going to be equal to stocks.locate, so LOC. Locate is going to take 2 arguments. So at first it's going to take an index, and then it's going to take a column. I'm just going to keep those there for placeholders right now. But basically what it's going to do is it's going to take some condition as an index or even a value, so just an integer. It's going to solve whatever indexes it needs to go to, and then it's going to look at whatever column you pass it. So basically what we are doing up here, just all in one bracket. So again, it's going to be, the index is going to be equal to the stocks at new date .dt.year equal to 2022. Now, instead of closing the brackets right there, we are going to now fill in what column we want it to return. And again, this is going to be the close column. So just like that, this is the locate function, and this is how I recommend to do it. You should always be using the locate function or the ilocate, which is going to take number values as well, or positional values of the rows and columns. But locate for now is the one that we're really going to want to use. And let's go ahead and run this. I do have an error. Again, I misspelled stocks. Okay, there we go. You can see we gained a little bit of performance, and that is typical with the locate, which is why you really should be using it to find any values or to reference any values within here. So that is maybe the most powerful one that comes with pandas, especially when you start using complex conditional statements. You could have multiple conditions in here that you want it to meet, or you can pass in and reassign multiple values, which is actually what we're going to do next. So let's start looking at, okay, I was able to find where these values were, but how do I reassign them once I figure out where they were? So expanding this one. We get this on frame here. All right, you're going to see we have our original code here. And what we're doing is we are looping through the stock data. Wherever the year is equal to 2022, I want to have some label that says it's this year. And wherever it's not, I want to say it's not this year. So very simple, just labeling whether it's this year or not. And then at the very end, we're going to create a new column called year, and it's going to store that label. But as you can see, again, just like all the other ones, this constant use of a for loop is going to make it go super slow. So we really need to find a way to make this happen without looping through every single thing within the data frame. And so to do that, we're going to do exactly what we did before, and that's the locate function. So stocks dot locate. And what are we looking for? Well, we need to know whenever the the year is equal to 2022. So let's go ahead and look for that. So whenever these stocks at new date, .dt.year equals 2022. Now remember, locate takes two arguments. The first is the index. The second is whatever column or columns you want to pass. In this case, we're going to make a new column, and locate will accept new ones. So if we put year in here, even though it's not in the data frame right now, it will make a new column called year. So this is on the left-hand side. So this means wherever this is true, we're now going to assign values to year at these indexes. So in this case, wherever the year is equal to 2022, we want it to be equal to this year. And we could copy this and come down here and say wherever it is not equal to 2022, we're going to say not this year. Now we can run this, and actually let me go ahead and run it. It shouldn't take very long. You see 5.9 milliseconds, but actually we probably can gain a little more performance out of this just by up here saying stocks at year is equal to not this year. So we're going to initialize the column to be not this year. We're going to remove the bottom, and now we're just going to change the ones that are this year to be this year. And we should be able to see a little bit of performance. Yep. So 3.17 milliseconds now. So really, again, locate and ilocate are going to be your best friends using pandas. It's super powerful, and you can quickly find values and also reassign values based on some condition. It's really where pandas gets the bang for its buck. Okay, some other things that are super useful. The next one will be mapping dictionaries. So you can think if you have a dictionary and you want to use the values as keys and you want to map whatever those are based in the dictionary to a new column or to the same column even. So as you can see, if you remember up top, we have this dictionary called sectors. Let me just scroll back up to the top actually. This is the dictionary right here. So it's going to take in the ticker symbol and it's going to return whatever sector it's in. So Apple is tech, 3M is industrials. Going back down to the bottom, what we're doing is doing a for loop over the stocks, and we're looping, and every time we are passing whatever the ticker is at each row, we're passing that as the key to the dictionary. It's returning the sector, and then we are saving the sectors as a new column. This case, we are doing this at 112 milliseconds, but we're going to see if we can increase that performance using pandas. This case, we're going to call stocks, and we're going to make a new column called sector. So stocks at sector is going to be equal to stocks at ticker. So we're mapping the ticker column, and we're passing the ticker values to the dictionary. To do this, we are going to use dot map. So this is mapping the ticker columns to the dictionary as the keys, and is looking for a dictionary to be passed in. And that's all. That's the entire code. So it's going to run through and it's going to map each one of those ticker values to the different sectors. If we run this, 2.45 milliseconds. That's, again, a huge jump in performance, and really why Pandas is such a great package. Now, dictionaries are great, but it's not always possible to use a dictionary. So sometimes you want to use complex functions or complex equations. So let's go ahead and look at how do we do sort of the same thing, but using functions instead. So as you can see, our original code here, we are going through each one of the prices, so each one of the days, and we're calculating what the percent change was. Now the percent change is going to be the closing price minus the opening price over the opening price. And you're going to see it right here. I added some buffer here just in case the opening price was 0. Maybe that's not how you actually would do it for stocks. It doesn't really matter for this tutorial. I just wanted to get it done. Basically, we're running through, we are for each line calculating what the percent change would be, and then we're assigning that array to a new column within the data frame. As you can see, this is probably the most expensive one we've seen yet, 344 milliseconds. So let's see if we can pare down that computational time. So to do this, we are going to say, again, stocks, we're going to make a new column called percent change. And percent change is going to be equal to stocks. Now, I'm going to you can pass in every single column. I'm only going to pass in the 2 that I care about. So to do that, you're going to do a double bracket, and you're going to pass in the columns that you want to actually include. In this case, I'm going to use the opening and closing columns. Make sure to end that double bracket there. In the first case, we're just going to do a simple lambda function. So we're going to apply. That's the function here. Instead of map for the dictionary, it's apply for functions. We are going to apply some function to these 2 columns and return it as the percent change column. In this case, our lambda function is going to be lambda x. And we're going to say, now, x is going to be a single row. And in this case, our row is going to have 2 positions. It's going to have the opening position and the closing position. So when we start to make or write this formula, we're going to have to reference that. So we're going to say x at 1. X at 1 is going to be the closing price. We're indexing these 2 right here. So it's going to be x at 1 minus x at 0. X at 0 is the first position, so the opening price. That is going to be divided by the opening price, x at 0. And then remember, we're just going to add this little buffer in here just in case the opening price is 0. Okay, so let's quickly recap what's going on here. So we are passing the function the opening and closing prices, and then we are applying those prices to a lambda function. And the lambda function is taking each argument, in this case, the first index, which is the second position in here, the closing price minus opening price over opening price plus some buffer will give us the percent change. Let's go ahead and run this one. Now this one, actually I already realized I had an error here. We need to say this is axis equals 1. Go ahead and run that. If you don't do that, it's going to do it for the entire array. So just make sure you're using axis equals 1. Now again, this is going to take a little longer because you're kind of doing more math, and so the computation is going to take a little longer. While that's loading, let's go ahead and look at some other ways of doing it. So maybe you don't want to type out a lambda function, or you can't fit what you're trying to do into a lambda function. So you're trying to do maybe a more complex function. You can actually just define a new function. So I'm just going to call this one percent change. Percent change is going to take in some value of x. And we'll get into what it is right now, actually. So basically what we had here is exactly what we're going to do. So if you go back up here to the lambda function, just copy this entire equation and paste it down here, and we're just going to return this. Now this is a fairly simple function. You may not want to do it for this, and you may have a lot of other logic that you're trying to do within this function. It doesn't really matter, but for the purposes of this, we're just going to return the percent change like we did before. Now, as you can see, we're still referencing x as 0 and 1. So again, it's passing in some subset of the data frame. Now, in order to call this, we're going to do very similar to what we did before. So we're going to say the stocks at percent change is going to be equal to the stocks. And again, we're only going to pass in 2 columns. You can pass in all of them if you want to, but just to keep it simple, we're only passing in 2. So we're going to pass in the opening and closing. We're going to apply the function. So in order to apply the function, you need to pass in the function name. We called it percent change. And we're going to say it's going to be axis 1. Okay, so very important here, I'm only passing in the name. I'm not passing in any arguments because these 2 columns right here are my arguments already. It's already passing in this line as the argument to percent change, and then it's taking care of it in the function. So go ahead and run that. Our other one it actually ran a little longer. Maybe I have something running in the background that's taking it a little longer because it should have gained us performance. Maybe we can go ahead and run that one again. I also was not recording when I ran the original one, so that could be also why it's taking a little longer for us to run it. Either way, the lambda function and the actually calling the function are not the optimal solution. These are just ways of doing it, and you're not going to be able to get around sometimes calling it this way. When you have a super complex function, you're not going to be able to do vectorized solution, which is the third solution I'm going to show you here. But when you can do vectorized solution, you definitely need to, just because of the performance gains. So let's look at how to do that. And you've probably already seen this because, again, this is another super useful case for using pandas, and it's one of the beginner things that you can do with it. But we're going to say the stock at percent change is going to be equal to these stocks at close. I'm going to put this in parentheses before I forget. I'm going to take the close column minus the stocks at the opening column, and I'm going to divide it by these stocks at the opening column plus some buffer. Okay, like I said, this is the optimal solution. So this is going to take and do it's going to vectorize the calculation instead of doing it one by one, like it's doing here with the mapping or the applying. So after this one runs, which again is taking a fairly long time, so I think it's because I'm recording at the same time, which is why it's not going faster than the original. But if I were to rerun the original, I am sure that it would run way longer than both of these. Yeah, 429 milliseconds, not great, but again, if I reran the original, I'm sure it would be somewhere 600, 700. So definitely we're getting a performance gain from this one. But like I said, if we run this final one here, again, now we're down to microseconds. So again, vectorized is definitely the way to do it. You should definitely try to get everything to be vectorized like this. If you can't, and it's definitely going to happen where you're trying to apply some very complex function to it and you're just not going to be able to do it as a vectorized solution. Totally get it. And it's inevitable. Okay, the last thing I'm going to go through is binning. So especially when you're doing something like machine learning, you're going to want categorical values. So you want to split your values into different categories based on whatever the value actually is. In this case, I just did a quick example here where we're looking at that percent change that we just made, and we're saying based on its value, we are labeling it as whether it's down a lot, down, up, or up a lot. And so our bins are really anything less than -2, anything between -2 and 0, anything 0 to 2, and then anything above 2. Those are our 4 bins. In order to do that here, we're doing a for loop, a whole bunch of if-else statements, and then finally, once we get all of our labels, we are assigning it to a new column. And as we've been hitting on this entire video, for loops are not the way to do this. It takes a lot of time. And luckily, Pandas does have a function built in to allow us to bin these easily. So this is going to look like stocks. I'm going to make a new column called bins. So bins is going to be equal to a pandas function called cut. So pd.cut. Now cut is going to take in a column. So we are going to pass it the percent change column because that's what it's going to be making its decisions based off of. So we're going to be looking at the percent change column and we're going to need to tell it what are the different categories that it needs to fit in. And to do that, we're going to give it the ranges of values that fit in there. So we're going to pass it a list. We're going to make some super small values. So I'm going to make it -1 million, just so it covers everything. This is our lowest bound of our first category. And then the upper bound is going to be -2. So anything -2 to -1 million is going to be labeled as our first category. Our second category is going to be -2 to 0. Third category is going to be 0 to 2. And our final category, we will make it 2 to 1 million. Let me make sure I don't have enough zeros. Okay. So while this is 5 values, it's actually only 4 labels because it falls in between. These are our limits. So there's one here, one here, one here, and one here. We could leave it like this, and it would give us the thresholds as the values, or we can go ahead and assign each one of these labels, which is what we're going to do. So I'm going to drop this down so my face doesn't block what I'm doing, but we're going to include something called labels. And labels is going to take an array of whatever you want to label each one of these. So if you look up top, we had down a lot, down, up, and up a lot. Go ahead and close that, and we can run this. Okay, it's already run. So before 297 milliseconds, now we are at 1.98 milliseconds. And I do actually want to just right now show what the data frame looks like. So display stocks. Okay, and you can see we have our bins now. And our bins are saying whether or not the stock is down, up, down a lot, up a lot, whatever it is, based on this percent change column right here. And so with that, that's just a quick idea of some of the more advanced things that you can do with Pandas. Now, It's definitely going to depend on your use cases, depend on what your data looks like, and depend on what you're trying to do with it. But you, especially when you start looking into machine learning with large data sets, it's going to be super important to make sure you are reading those in optimally, because it can take you hours and hours to read the data. And so you want to shed off any sort of time savings you can, because it's going to compound, and it's really going to save you a lot of time. But again, with that, that's what we can do. Stay tuned for more stuff. And if you want to check out some more of this financial data, I do have a few series on using machine learning to predict stock data. So this kind of is a good segment into that as well. But I will see you in the next video, and thanks for tuning in.